electric field due to a line of charge. Look at this diagram. This is a line of charge of uniform charge density. Lambda be the charge density and total charge is Q. Let this line of charge produces electric field capital E on a cylindrical Gaussian surface. Let this be the cylindrical Gaussian surface enclosing the charge Q. It has got a plane surface on top and bottom side. Bottom side is also a plane surface. Top side is also a plane surface, whereas it has got a curved surface also. Now, what is the area vector on the top and bottom plane surface? Let A be the area vector. We can see this area vector makes an angle 90 degree with this electric field. Area vector is making an angle 90 degree with this electric field. Similarly, at the bottom flat surface also, the area vector A, which is perpendicular to the plane of the surface, and here we can see electric field is acting perpendicular to the area vector. This is the electric field. So I represent the electric field as capital E, area vector A, between them there is an angle 90 degree. Since electric field and area vector are making an angle 90 degree, electric flux phi E, due to electric flux phi E, or simply we can represent as phi naught, whatever it is. Phi E is equal to E dot A. Both are vector quantities, and we know this is EA cos 90 degree, which is equal to 0, cos 90, 0. Now, look at the curved surface. The curved surface, it's a closed surface. The cylinder is having radius R. R is the radius of the cylinder, and L is the length of the cylinder, or L is the length of this line of charge also. In such case, the electric flux phi E dash I write due to the electric flux over the closed curved surface. Phi E dash equal to electric field is same E dot area vector E dot A. I just write that area vector to be A dash there. This area is different, curved surface area is different. So E dot A dash, which is equal to E into total area of the curved surfaces 2 pi R into L. So this is the total flux which crosses through the curved surface. According to Gauss theorem, integration over the closed surface, this is the surface what we consider, E dot ds is equal to q by epsilon naught if we consider the entire system is kept in free space or vacuum medium. If we solve this, we can write E dot ds, that is total flux phi E dashed. Phi E is 0, total flux is only phi E dashed, which is equal to E into 2 pi r L, which is equal to q by epsilon naught. Already we know integration over the closed surface E dot ds is equal to phi E dashed. These are the vector quantities. Now, if we solve this, we get E equal to q by epsilon naught whole divided by 2 pi RL. Now, what is q here? Q is the total charge. Lambda is the charge per unit length. Hence, we can write Q is equal to lambda times L. Substituting the value of Q here, we can write lambda L divided by 2 pi r epsilon naught L. This L get cancelled out. Ultimately, we get the result as lambda by 2 pi r epsilon naught, which is the magnitude of electric field due to the line of charge over this Gaussian surface, which is having radius r and length L. But if we write in terms of vector E equal to lambda by 2 pi r epsilon naught into unit vector r. This is the total electric field due to a line of charge density lambda at distance r from it. So E depends on lambda, r and absolute permittivity epsilon naught, since the system is kept in vacuum medium. Thank you.